folks, what I would like to do is I would like to do problem 314. If you go back to the applications that we talked about, there was one area was the staffing. Now here is a problem on staffing. So this is a computer lab, okay, in which we have two kinds of workers. One are called the full-timers, the other one are the part-timers. Okay, the full-timers report to work at 8 o'clock in the morning and they get off at 4 o'clock, and there are ones who join at 12, get off at 8, and the third set comes in at 4, gets off at midnight. In addition to the full-timers, okay, for 4-hour slots, the part-timers can be hired also. So from 12 to 4, if you look at it, there are full-timers who started at 8, the one who started at 12, those two sets we have, joined by part-timers. So these are the relationships that we need to bring into the model over here. The full-timers are paid $14 an hour. Since they work 8 hours, is $112 per shift, and the part-timers, they earn $12 per hour, and they make $48 per shift. Okay. So in the time slot is 8 to noon, noon to 8, noon to 4, 4 to 8, and 8 to midnight, and they need at least 6 workers, 8 workers, 12 and 6 workers in those time slots. So we had to have the staffing, minimum staffing that we need. In addition to that, there is also another stipulation that for each part-time person, there should be at least 2 full-timers. Okay, there should be at least 2 full-timers, meaning that if there is one part-timer here, we should have at least 2 full-timers for that person here. So that's a relationship we need to make sure that happens. So the objective here is to staff, okay, the lab through hiring full-timers and part-timers, and also making sure that this stipulation is met, but keeping the cost to minimum. Okay, so that's what we need to do. So first, here are the decision variables, and the total full-time that are there from 8 to noon, if you look at it, so that is that B18, that refers to that cell. Now here, if you look at it, that refers to those who started at 8 and those who are joined by at noon. Okay. Now the third one, if you look here, it is those who started at noon and joined by those at 4 o'clock. So the part-timers here are nothing but they basically get written down here once we solve the problem. The total employees is the sum of the full-timers and the part-timers. See, the total employees are the sum of the full-timers and the part-timers in the time slot. So the same relationship is there as you see through at the other two places. So this number should be greater than or equal to that, and the total full time, now I refer back to here, okay, whatever that gets written down over here passes that information here. So that should be greater than or equal to twice the number of the part-timers, twice the number of the part-timers. So this is where the part-timer solution would be written. Okay. The wages for the full-timers are nothing but the 112 times the number who join you at 8 o'clock, that is that, and likewise here that is 112 times those number of full-timers who come at 12 noon, and likewise here 112 times those numbers that come at 4 o'clock. The part-timer is straightforward. Here it's nothing but 48 times the number of part-timers that start at 8, and likewise for the other 4 time slots. So the total wages is nothing but the sum of the total full-time plus the total part-time. So sum command 418 through 420 is that, comma, L18 through L21 is that. So that basically sums up. So what we had to do is then let us build the solver. Okay, go to data, go to solver. If you don't see solver on your machine, go through the add-ins, then add the solver into that. Let me know through email if you are able to, or on the discussion board, put it up to see, if you have problems installing the solver. Okay, if you have it, then I will send an email out to you as how to install that. Okay, the objective here is, that is, my objective is to minimize the cost, and my decision variables are the number of full-time people that we need to have, that is one set, comma, okay, space, the number of part-timers. So we can pass this information like at various places through separating them by commas. Okay, subject to constraints, add constraints that the total number of employees should be greater than or equal to the required, that is 1. Add the constraint, the stipulation that we had to have at least 2 full-time employees for each part-time employee that we have. That relationship is right there. So we have passed that information. Click OK. Options. Assume linear. Check that one. Assume non-negative. Those 2 boxes should be checked. Click OK and solve. So here solver found a solution. All constraints are satisfied. So that's what we have. That's information. We need at least 6. We got 6. Total employees. We need at least 8. We got 8, 12, and 12, 6, and 6. So this is met through getting 4 employees, full-time employees, to report at 8 o'clock, asking 2 of them to report for work at 12 noon, and 6 people to join at 4 o'clock. Number of part-timers, you ask them 2 to come from 8 to noon, 2 to 12 to 4, and 4 from 4 p.m. to 8 p.m. and none in the 8 p.m. to midnight slot. Okay, so we need at least 2 full-timers for each part-timer. We have that here. Here, see, total full-time, at least twice that. Here we have 6, at least twice. Yes, that is there. We have 3 times. Twice here, that is satisfied. At least twice here, of course, it is satisfied there too. So we met all the conditions. It's going to cost us $1,728 to staff that. If you build the same spreadsheet yourself and solve, you might get a different answer here, okay, but nonetheless it would meet these needs and it will keep the cost at the same. Okay, that's okay, because that is called another best solution, another optimal solution that we have, which gets you the same money. I mean, as long as the objective function is the same, if the solution looks different and meets all the conditions that we have, then it's another alternate optimal solution. That's okay. That's okay. Okay, so both answers are correct. Okay.